Okay, so for this example, we want to graph f of x equals 2 cosecant of x divided by 2 minus pi divided by 2. So to graph this, we need to consider the reciprocal function. Cosecant's reciprocal is sine. So we're really going to graph 2 sine of x divided by 2 minus pi divided by 2. And then we can take the reciprocal graph from that. So to start it off, how do we graph sine? Well, remember we take whatever's in parentheses, this x divided by 2 minus pi divided by 2. We're going to set that greater than or equal to 0, but also less than or equal to 2 pi. To start off with, the first thing that we can do here is add this pi over 2 to each side, or we could multiply everything by 2 to immediately get rid of our fractions. Either one's perfectly fine. I'm going to go ahead and multiply by this 2 though, as it'll make this a lot easier to work with. So 0 times 2 is 0. That's less than or equal to x divided by 2 minus pi divided by 2. If we were to distribute this 2 to each of them, we'd end up with x minus pi. The division by 2 would cancel in both cases, and then that's less than or equal to 2 pi times 2 is 4 pi. And finally, from here, to get x alone, we would add pi to all three of these values, which gives us pi is less than or equal to x, which is less than or equal to 5 pi. And now, from here, we have an entire period of our graph, so we will now find the period, which is 2 pi divided by b, and b in this case is the number in front of x, the number multiplied to x. Since x is being divided by 2, then that's the same thing as saying it's being multiplied by 1/2. It's just another way to think about it. So that means b is equal to 1/2. So 2 pi divided by 1/2 is the same thing as 2 pi times the reciprocal. Remember, if you're ever dividing by a fraction, you can multiply by the reciprocal. So we get 2 pi times 2 over 1 instead of divided by 1 over 2, which gives us 2 pi times 2 is 4 pi. Okay, and now that we have our period, we take p and divide it by 4, which gives us 4 pi over 4, meaning our period divided by 4 is pi. That's the value we're going to add 4 times to the start of our inequality. So we'll make our table. We start at the left value, pi, and we add p over 4, which in this case is pi, 4 times to that value. So we have pi plus pi is 2 pi, plus pi is 3 pi, plus pi is 4 pi, and plus pi is 5 pi. We've added it 4 times. Let's check the initial value and the end value. They match the inequality, so we've probably done this correctly. It's just a quick check we can do. Now, remember whenever we graph sine, the graph always starts with 0, goes to 1, back to 0, down to -1, back to 0. So, as long as we remember these values, these are our quadrantal angles values, then we can immediately get the initial sketch of sine. And from here, we're going to go ahead and list off our transformations and begin graphing. So we only need to worry about the vertical transformations. Remember, this process takes care of all the horizontal transformations. So we check, are we multiplying the outside of our function by a negative? No. So there's not a vertical reflection. Now, are we multiplying by a number between 0 and 1? No. So there isn't a vertical shrink. Are we multiplying by a number greater than 1? Yes. So there's a vertical stretch. That's going to be our first type of vertical transformation. We have a vertical stretch. And now from here, we check, is there a number added or subtracted to the outside? There is not. So that's it. We only have one vertical transformation. It's our vertical stretch. So we can begin graphing our table and then apply the reciprocal and then finally apply the only vertical transformation we have. So we have the point pi comma 0. So we'll start with pi and then we'll go up to 5 pi. So we have pi, 2 pi, 3 pi, 4 pi, 5 pi. We have the point pi comma 0, 2 pi comma 1, 3 pi comma 0, 4 pi comma negative 1, and 5 pi comma 0. We connect these dots. So that gives us our initial graph. Now we can, in red, graph sine's reciprocal, that is, cosecant from this. So remember, wherever we have zeros, those are vertical asymptotes. And from here, wherever we have a hill, that means we're going to have an upward-facing parabola shape. So our hill starts at this value of 1, and then it's going to go upward, like this. And wherever we have a valley, we start at that same point at the bottom of the valley, and now we have a downward-facing parabola shape. And from here, we can apply the vertical stretch. So the vertical stretch, we take this value, so the bottom of this upward-facing parabola, and we multiply it by the number on the outside, the 2. So we have y equals 1 here. We're going to go ahead and put this in blue. When we multiply by 2, this value is going to go up here. And then we stretch out all the other values. So for instance, these two values on the red graph are technically at y equals 2. If we multiply them by 2, they'd be at y equals 4. So what's that going to look like? It looks like our parabola shape got stretched out like so. It almost looks narrower, but remember, don't confuse this with getting narrower. It's getting longer. That's a vertical stretch. The same thing will happen here. At negative 1, we multiply by 2, it's going to become negative 2. So this point comes down here, and now we stretch this parabola shape downward to look like so. And this graph in blue with the vertical asymptotes is the graph of f of x.